Imagine an object so dense that a single teaspoon of its material would weigh billions of tons on Earth. An object only about 20 kilometers across, yet containing more mass than our Sun. This isn't science fiction. It's called a neutron star, and it is born in one of the most violent events in the universe. But how can an enormous star end up becoming something so unbelievably small and dense? Let's travel billions of years into the life of a giant star to find out. Every star begins as a giant cloud of gas and dust. Over millions of years, gravity pulls this material together until the pressure at the center becomes so intense that nuclear fusion begins. Hydrogen atoms fuse into helium, releasing enormous amounts of energy. That energy pushes outward, while gravity pulls inward. For millions of years, these two forces remain perfectly balanced. This balance keeps the star alive. But no star lives forever. Eventually, the star starts running out of hydrogen fuel. To survive, it begins fusing heavier and heavier elements. Helium becomes carbon, carbon becomes oxygen, then silicon, finally iron. And this is where everything changes. Unlike the earlier reactions, fusing iron doesn't release energy. Instead, it consumes energy. The star's engine suddenly begins to fail. The outward pressure weakens. Gravity finally takes control. Without enough pressure to support itself, the star's core collapses in less than a second. The atoms are crushed together with unimaginable force. Electrons are pushed into protons. Together, they form neutrons. The core becomes an enormous ball made almost entirely of neutrons. The collapse is so violent that the outer layers of the star rebound outward in a gigantic explosion. This explosion is called a supernova. For a short time, a single exploding star can outshine an entire galaxy. After the explosion, only the core remains. If that leftover core has roughly 1.4 to 3 times the mass of our Sun, gravity crushes it into a neutron star. But if the core is even more massive, not even neutron pressure can stop gravity. The collapse continues. Space and time themselves are pulled inward. A black hole is born. Whether a dying star becomes a neutron star or a black hole depends mainly on how massive its core is after the supernova. A neutron star is only about 20 kilometers wide, yet it can contain more mass than the entire Sun. Its gravity is so strong that if you stood nearby, the difference in gravity between your feet and your head would be enormous. Some neutron stars spin hundreds of times every second. Others send powerful beams of radio waves into space. When those beams sweep past Earth, astronomers detect regular pulses, which is why these objects are called pulsars. They are among the most accurate natural clocks ever discovered. Every neutron star is the silent heart of a star that once lit up the universe. Its incredible birth reminds us that even in death, stars continue to shape the cosmos. And perhaps the most amazing fact of all, many of the elements that make up our planet, and even our own bodies, were forged inside ancient stars that exploded long before the Earth ever existed. In a very real sense, we are made of stardust.